Hello, welcome to the SANGFOR Network Secure Training course. In this course, we will introduce the basic network concepts and firewall deployment mode, including firewall interface, zone, routing, address translation, and different deployment modes. First, let's introduce the interface and zone. Most of the configurations of firewalls are based on interfaces, and the interface is a bridge for communication with other devices. The configuration of the interface is also different depending on the deployment mode. Regarding interfaces and zones, interface need to be bound to specific zone, but zone do not necessarily need to be bound to interface. An interface can only be bound to one zone, but a zone can contain multiple different interfaces associated with it. Firewall divides interfaces into two categories: physical interfaces and logical interfaces. Physical interface refers to the real interface of the physical device. Logical interface refers to virtual interfaces created from the software level, where logical interfaces can be divided into sub-interfaces, VLAN interfaces, aggregate interfaces, and GRE tunnel interfaces. Sub-interface is used to create logical sub-interfaces on a physical interface and configure VLAN tags to achieve communication between different VLANs. The VLAN interface enables VLAN on the Layer 3 interface in a layer to transparent environment, thereby realizing network communication between VLANs. The aggregation interface is used to aggregate different physical interfaces to form a logical interface, thereby increasing link bandwidth and realizing link redundancy. The GRE tunnel interface is used to create GRE tunnels, mainly used to establish virtual point-to-point connections between different networks, and supports the encapsulation and transmission of multiple network protocols. Depending on the usage scenario, the interface type is also different. The firewall supports the following four interface types: Layer 3 interface, Layer 2 interface, virtual wire, and mirror interface. Layer 3 interface supports routing and data forwarding and other features. The second layer interface forwards data based on the MAC address table and can be distinguished into two working modes: access and trunk. The virtual wire interface is used to connect to different physical lines. The physical interface forms a logical line, just like a physical cable connected in the middle of the network. The mirror port is used to analyze the mirrored data. This interface will only receive and analyze data and will not forward data. The interface of the firewall corresponds to the physical interface. The physical interface can be defined as a Layer 3 interface, a Layer 2 interface, a virtual wire, and a mirror interface. The first three interfaces support WAN attributes, and WAN attributes means that the interface will have features such as policy routing, bandwidth management, traffic auditing, session ranking, IPsec VPN, etc. It should be noted that the physical interface cannot be deleted or added directly, because the physical interface depends on the physical device model. By default, ETH0 is designated as the out-of-band management interface on SANGFOR Network Secure devices. This interface is dedicated to device management and does not participate in regular traffic forwarding. A Layer 3 interface is responsible for routing and forwarding traffic based on IP addresses. It acts as a gateway for connected subnets and supports various advanced features such as NAT, bandwidth management, and traffic auditing, but only when the interface is configured with the WAN attribute. For the Layer 2 interface, you can understand that the Layer 2 interface is a normal switch interface. It does not require an IP address and does not support routing function, just forward data based on MAC address table. If you need this interface to support VPN, bandwidth management, and other features, you can also enable WAN properties. For virtual wire interfaces, you can treat virtual wire interfaces as a normal switch interface. This interface also does not support routing functions and does not require IP configuration. It should be noted that the virtual wire interface does not forward packets based on the MAC address table, but directly forwarding data to another interface of the virtual wire, so you need to configure the virtual wire to specify two specific physical interfaces to form a virtual wire. Sub-interfaces are usually used in single-arm routing scenarios to allow networks of different VLANs to communicate. It should be noted that the sub-interface is a logical interface and can only be configured based on the physical interface, and the corresponding VLAN tag needs to be configured for the interface. Regarding VLAN interface, a VLAN interface is a logical interface used to create a Layer 3 interface for a specific VLAN on the device to realize communication between different VLANs. At the same time, this interface supports the configuration of IPv4 and IPv6 addresses, which are mainly used to realize communication between different VLANs. Notes on interfaces. First, in the scenario where multiple ISP lines are available, the firewall supports multiple routing interfaces that enable WAN attributes. But additional license is required. The second point is that the routing interface can add multiple different sub-interfaces, but the IP address of the routing interface and the IP address of the sub-interface cannot conflict. Third, except for the routing interface that supports NAT function, no other interfaces support NAT function. Fourthly, GRE tunnel supports packet transmission of IPv4 and IPv6 protocols, but GRE tunnel interface only supports it via v4. Fifth, the data forwarding performance of the virtual wire interface is higher than that of the Layer 2 interface. In the scenarios of single in and single out and double in and double out, it is recommended to use the virtual wire interface when deploying the firewall. Zones are divided into different security levels according to the security needs of the network architecture to define different security domains. Through zone division, administrators can implement precise access control and security policies on traffic between different zones, thereby effectively managing and protecting the network. For the Layer 2 zone, only the Layer 2 interface and mirror interface are supported. For the Layer 3 zone, all the Layer 3 interfaces can be selected, including the Layer 3 interface, sub-interface, VLAN interface, and GRE tunnel interface. For virtual wire zones, only virtual wire interfaces are allowed to be selected. There are two ways to configure the zone. The first is that you can select the corresponding zone when configuring the interface information. The second way is that you can configure the zone and the type of zone separately, and select the interface belonging to the zone. Next, we introduce routing. According to different usage scenarios and different routing types, the firewall supports the following routing forms: direct connection routing, policy routing, SSL VPN tunnel routing, IPsec VPN routing, destination address routing, and default routing. Usually we use policy routing, static routing, and destination address routing. Default routing. The following routes are reduced from top to bottom priority, which is the default route order. You can also adjust the order of these routes in your system configuration to suit your needs. Policy-based routing (PBR) allows network administrators to fine-grain control of the forwarding path of data packets based on predefined policies. Unlike the traditional routing mechanism based on destination address, policy routing can determine its forwarding path based on multiple parameters such as the source address, destination address, protocol type, and port number of the packet. The main function of IPsec VPN routing is to ensure confidentiality, integrity, and authenticity of data when transmitted on public networks such as the Internet by establishing secure encrypted tunnels between two network nodes. Destination address routing, which is commonly referred to as static and dynamic routing. You can manually configure static routing to specify a specific destination address to be transmitted over a specific path. Dynamic routing protocols such as OSPF and BGP can also be used to automatically exchange routing information between routing devices and dynamically update routing tables. Next, we will focus on the most commonly used static routes and policy routes. Static routing refers to a fixed route manually configured by the network administrator according to the destination address. Allows the firewall to implement packet forwarding according to statically configured routes. The usual formats are destination segment, mask, next hop, interface, and measurement values. You can manually add one or more routes in the following path. When adding a single route, you need to fill in the destination address, mask, and corresponding network port, which is usually selected as automatic. You need to select the next hop address, as well as management distance, measurement value, availability detection. If you are adding multiple routes, you can manually write them according to the format of the route. Next, we introduce policy routing. Policy-based routing (PBR) allows network administrators to fine-grain control of the forwarding path of data packets based on predefined policies. Unlike the traditional routing mechanism based on destination address, policy routing can determine its forwarding path based on multiple parameters such as the source address, destination address, protocol type, and port number of the packet. Policy routing mainly uses two scenarios. The first type is based on source address policy routing. When there are multiple WAN lines, the matching conditions are defined based on the source or destination IP, port, protocol, and application. For the matching traffic, the WAN interface or next hop of the specified line is selected according to the selection. The second type is link load routing. In multiple line scenarios, matching conditions are defined based on source or destination IP, port, protocol, and application, and polling, bandwidth ratio, weighted minimum traffic for the outgoing interface, and priority is given to the previous line strategy. Dynamically select lines to achieve effective utilization of line bandwidth and load balancing. Taking multi-line load as an example, when creating a policy, you can specify different source zones, source addresses, destination objects, applications, and corresponding outgoing interfaces. The following are several notes regarding the default routing priority, from high to low, direct connection routing, policy routing, SSL VPN tunnel routing, IPsec VPN routing, destination address routing, and default routing. You can manually adjust the priority of the path in the system options. The second point is that link status detection must be enabled for multi-line loads, thereby achieving automatic failover. Next, we introduce network address conversion. Network address translation refers to converting the IP address in the packet header from one address to another when an IP packet passes through a router or firewall. It is usually used to allow private network users to access public networks to alleviate the problem of insufficient available public network IP addresses, and can also be used to allow users to access intranet services from public networks. According to different usage scenarios, network address conversion is usually divided into the following types: source address conversion, destination address conversion, bidirectional conversion, mutual conversion of IPv4 and IPv6 addresses. Source address translation is used to allow multiple internal devices on the private network to share one or a small number of public IP addresses to access the external network, thereby alleviating the problem of IPv4 address shortage. Destination address translation refers to the process of converting the destination IP address of the data packet into a specific IP address in the internal network when it is sent from an external network to an internal network. A typical usage scenario is to configure address conversion policies on the egress routing device or gateway device. Two-way address translation is used to allow users of the intranet to access the intranet services through the public IP on the egress or gateway device, thereby maintaining consistency between the internal and external network services. NAT64 and NAT46 are two network address translation technologies designed to solve the problem of interoperability between IPv4 and IPv6 networks, and ensure that devices with different protocol versions can communicate with each other. Next, we introduce a typical source address conversion case. The firewall serves as an internet gateway and is connected to a layer 3 switch at the same time. The intranet has a PC and a server. PCs and servers that require intranet to access the internet through firewalls. Our solution is to configure source address conversion policy. Step 1. Check the interface information to determine which interface is used as the outgoing interface and the corresponding public network address. At the same time, it is necessary to determine the network port and corresponding address of the intranet. Step 2. We create the interface and the corresponding zone. Step 3. We create an address group. The address group depends on which source addresses we want to convert, that is, the specified network segment of the intranet. Step 4. Configure the source address conversion policy. We need to select the policy type as source address conversion, corresponding source zone, source address, destination zone, and corresponding outbound interface. In the second scenario, we need to convert the target IP address requested by the externally to a specific IP address in the internal network, allowing external users to access the internal server or service through the public IP address. From the network top, you can see that there is a web server on the intranet. We need to pass The target IP address requested by the external request is converted into a specific IP address in the internal network, thereby accessing the web server on the intranet. Our solution is to configure the destination address translation policy. The first supplement is to check the interface information and determine which interface is used for the destination address conversion. We need to ensure the corresponding WAN attributes of the external network port line, because the interface enables the WAN attribute to support the network address conversion function. We confirm that the IP is correct. Step 2. We define the interface and zone. Step 3. We need to configure the destination address conversion policy. First, we need to select the address conversion policy type as the destination address conversion. Then we need to select the corresponding source zone, source address, to convert the destination address and service type, and we can directly fill in the IP address of the WAN port's destination address. For intranet servers, fill in the intranet web server and corresponding port. Next, we introduce the deployment model. According to different usage scenarios, firewalls can be deployed in the network in different modes, including one of the following methods: routing mode, bridge mode, virtual wire mode, mirror mode, and hybrid mode. For routing mode, you can understand that the firewall acts as a 3-layer gateway device, which can realize routing forwarding and network address conversion. VPN. Protection and security functions. Commonly used to deploy on the internet edge. The bridge mode can be understood as a switch with management and control functions. No need to configure an IP address, forward data according to the MAC address table. Virtual wire mode can be considered a special bridge mode. Packet forwarding does not depend on the MAC address table, but forwards data directly based on the interface specified by the virtual wire. Mirror mode is used to listen to data, such as auditing without forwarding data. Mixed mode allows different interfaces to use different deployment modes suitable for use in complex network environments such as data centers. Next, we will focus on the routing mode, bridge mode, and virtual wire mode. For routing mode, the usual requirement is that routing devices that require a firewall to replace the egress as gateway devices for the egress. From the topology, you can see that a switch is connected to the firewall. At the same time, there are a large number of endpoints and servers in the user zone and server zone of the intranet. Let's first analyze what preparations we need to do before deployment. First, it is necessary to analyze the internal and external network interface configuration. Second, it is familiar with the intranet network segments, such as how to divide network segments to facilitate writing backhaul routes. Third, confirm whether the intranet server needs to be published to the public network. Fourth, confirm whether the intranet users need to access the internet through address conversion. Chapter 5. What controls are needed to confirm the permissions of internal and external networks? 6. Confirm which security protection policies need to be configured to achieve network protection. 7. Review the entire network topology to check whether the deployment covers user needs. For internal and external network interface configuration, we need to configure the IP address of the interface. For internet interfaces, we need to enable WAN attributes and select the corresponding zone and type of the interface. For intranet interfaces, we need to configure the IP address, but we do not need to check the WAN attribute. Then select the intranet interface to select the corresponding zone and interface type. For routing, default routes and backhaul routes need to be configured so that the firewall can know how packets in different destination network segments should be forwarded. For NAT policies, it is necessary to configure source address translation so that the intranet PC and server can access the internet. If you need to publish an intranet application to the public network, you need to configure an additional destination address conversion policy. For access control permissions, new application control policies are added, and data access permissions from inside to outside are released. You need to select the corresponding source zone, source address, destination zone and destination address. For network security, botnet protection, IPS and other policies need to be configured. Let's summarize the characteristics of routing mode. First, the firewall deployed in routing mode is usually deployed at the edge of the internal and external networks, thereby realizing functions such as routing address translation. Second, the routing mode supports most features such as address translation, policy routing, dynamic routing, etc. Third, routing patterns usually change the original network topology. Fourth, for routing mode, configuring routing is necessary, such as default routing pending. Bridge mode, you can see the following typical network topology. There are already routing devices that act as network egress gateway devices. You need to use a firewall to connect to the middle of the network for management and security protection. Let's sort out what configurations you need to consider before deploying. The first step is to define the interface, which interfaces are connected to different devices upstream and downstream. Step 2. Define the management interface. Which address is used to manage firewall devices? Step 3. Configure routing. Step 4. No need to configure network address translation policy. Step 5. Configure access control policies to control traffic between the intranet and external networks. Step 6. Configure security protection policies. Next, each configuration step is described in detail. For interfaces, configure the physical interface of the bridge, including the interface working mode, access mode or track mode, and fill in the corresponding VLAN ID. For management interfaces, the ETH0 interface is usually used as the management interface, and the IP address and gateway are configured for the ETH0 interface. For routing, configuring default routes and backhaul routes, it should be noted that this route allows the firewall to access the internet and communicate with other devices, rather than forwarding packets through the firewall. For application control policies, thereby controlling access rights to the intranet and external networks. For network security policies to protect customers' network security. For specific configuration details, please refer to the configuration steps related to routing mode. Next, we introduce the serial network mode. You can see the following topology. Users own routers and switches, and use aggregation ports to increase link stability. Firewalls are required, transparently deployed between routers and switches. The user requires the data forwarding of the firewall and forward according to the upper and lower connection lines and top. At the same time, the firewall can control and protect traffic flows. By sorting out user needs, we can initially determine the use of bridge mode or virtual network cable mode. But we need to think about the difference between bridge mode or virtual network cable mode to determine which one to use. First, we know the virtual wire mode. The virtual wire mode is similar to the bridge mode and uses the layer to interface. The second point is that the data packet forwarding is not directed according to the MAC address table, but rather directly forwarded the data according to the specific interface. Third, the virtual network cable mode has higher forwarding performance, so we finally decided to use the virtual network cable mode. Next, we will configure the virtual network cable mode. For physical interfaces and lines, select an idle physical interface to generate virtual wires. At the same time, you need to configure a virtual wire pair and bind two interfaces to make these two interfaces form a virtual wire one. Configure the second virtual wire pair, select the other two idle interfaces, and configure and bind these two interfaces to form the virtual wire 2. Then configure the management port so that the firewall can be accessed by the administrator through the management port. Configuring routing requires the default route and packet back route. It should be noted that this route allows the firewall to access the internet and communicate with other devices, rather than forwarding packets through the firewall. Access control policy to realize permission management of internal and external zones of the firewall. Configure network security policies to detect customer traffic, such as whether there are IPS attacks, web attacks, botnets, etc. For detailed configuration details, please refer to the configuration details of routing mode. The above is the content of this training. Thank you for watching. Goodbye.